Hi everyone, let us learn what is differentiator and how to determine the output voltage for this differentiator circuit and how to determine the transfer function for this circuit. So here the differentiator is the special case of high pass filter. Okay. So what is that special case? The special case is where the time constant tau should be much less than the time period of the input signal. What is the time period of input signal? Here we are taking it is capital T, and where the input signal is Vn here, and what is time constant tau? It is nothing but product of resistor and capacitor. Okay, now let us first identify the in which configuration the op amp is connected. So here the op amp is connected in inverting configuration. Inverting configuration. How? So here the input V in is applied to inverting terminal through capacitor. Inverting terminal through capacitor, and non-inverting terminal is grounded. Non-inverting terminal is grounded so that it is connected in inverting configuration. Okay. Now, so here this differentiator is called as active differentiator. Why it is called as a active differentiator? Why? Because here the differentiator is designed or constructed with active elements. What are the active elements here? The active element in this circuit is op amp. Op amp is the active element, so that it is called as a active differentiator. Okay. Now let us assume the potential at inverting terminal is V minus and potential at non-inverting terminal is V plus, and the voltage across this capacitor is Vc. Okay. Now let us assume that the current flow due to this input source Vn is I1. Now this current I1 is reached to this node V minus. What will happen? At this node we having two paths. Now this I1 current is divided into these two paths, so that the current flow in inverting terminal is I minus and the current flow in resistor is I2. So it means that I1 is nothing but summation of I minus plus I2. Now according to virtual ground concept, potential at inverting terminal is equal to potential at non-inverting terminal. So for this circuit the non-inverting terminal is grounded. It means the potential at non-inverting terminal is 0, so that potential at inverting terminal is also 0. V minus equals to 0. And due to high input impedance, of op amp, ideally it is infinite and practically it is 1 mega ohms. Due to this high input impedance, the current flow in inverting terminal is equal to current flow at a non-inverting terminal is equal to 0. So now what will happen? I1 equals to I minus plus I2 can becomes as I1 equals to I2. So the flow of current through the capacitor is equivalent to the flow of current through the resistor. Okay. So here we can derive the output voltage Vout in two ways. Either you can use nodal analysis or either you can use these currents. Okay, for example, let us use this currents. What will happen? Okay, now let us derive. According to this, I1 equals to I2. Okay, now we are considering the voltage across the capacitor is Vc. So that Vc equals to Vn minus V minus. Okay, Vc is nothing but the voltage difference between input voltage Vin and inverting terminal voltage. So that what happens, already we know that according to virtual ground concept, V minus equals to 0. So that Vc equals to Vn. Okay, Vc equals to Vn. Now we know that I1 is current flowing, current flow in capacitor, current flow in capacitor. Okay, so that we know that I1 can be written as C into d by dt of Vc of t. Okay, so that we know that already I1 equals to I2. So that when I1 equals to I2, you can write it as, in place of I1 you can write it as C d by dt of Vc of t is equals to I2. What is I2 in this circuit? The I2 is current flow through the resistor. So I2 can be represented as the voltage difference of across this resistor divided with resistor R. So what is the voltage difference between V minus and V out? Is the voltage difference across the resistor R. So that you can write it as V minus V out by R. Okay, so already we know that according to virtual ground concept, V minus equal to 0. You can write it as C d by dt Vc of t is equals to minus V out by R. Okay, now what we want to determine? We want to determine V out. V out equals to minus RC d by dt of Vc of t. So final output is, here it is. So here this is a differentiator circuit. Differentiator circuit means the output which is V out is proportional to the differentiation of input voltage. Okay, so but here we got it as Vc of t. What is Vc of t? Already we determined the relationship between the Vc and Vn. So what is Vc and Vn? So here it is Vc equals to Vn here. So that in place of Vc you can write it as Vn. So that here V out equals to minus RC d by dt of, in place of Vc you can write it as Vn. So that according to the definition of the differentiator, the output of the circuit is proportional to the differentiation of the input applied it to the circuit. Okay, so what is RC here? The RC is the proportionality constant. What is minus indicates here? Here the op amp is connected is inverting configuration, so that it can be represent the inverting configuration where the input and output are having a phase shift 180 degrees. Okay, so this is the one way how to determine the output voltage. At the same time, you can use the nodal analysis. Either you can use nodal analysis. So let us do the nodal analysis. Okay. So according to the nodal analysis, at node V minus. So what is the node equation at node V minus? The node equation is V minus V in by capacitance plus V minus V out by R. Okay. So the node equation is V minus V in by capacitance, which is nothing but 1 by j omega c, plus V minus V out by R equal to 0. So according to the virtual ground concept, V minus equal to 0, you can write it as minus V in into j omega c minus V out by R equal to 0. Now what is V out by R? V out by R equals to minus V in j omega c. So V out equals to minus j omega RC V in. So already in the previous session where we discussed the integrator, already I explained. So j omega can be represented as, in Laplace it as S. So if you want to represent S as d by dt, differentiation of some factor. At the same time, 1 by j omega can be represented as 1 by j omega can be represented as 1 by S, and it is nothing but integral of some factor with respect to time. Okay. So what happened here? Here we got V out equals to, so this is our final V out value, but here it is a differentiator. You can represent in terms of differentiation of input. So in place of that, minus j omega, in place of j omega you can write it as differentiation, that is d by dt of omega. So j omega can be represented as S, so that is RC V in. Okay, so RC as a constant, that is a time constant, you can take it out. So V out equals to minus RC d by dt of V in. So finally we got the same expression what we got by using node currents. By using node currents here we using nodal analysis. So anyway we got the same answer. You can do any method. Okay, so this is the way how to determine the output voltage for the differentiator circuit. And now you have to determine the transfer function. So the transfer function, which can be represented as h of j omega, or you can represent it as h of s. So if you represent in h of j omega, so whatever the transfer function is nothing but ratio of output by input. So what is, so already we know the output. So output is nothing but see here, the output is nothing but in terms of j omega, that is V out equals to minus j omega RC V in. So that you can write it as, now I am writing here, V out equals to minus j omega RC V in. So that now what will happen, V out by V in gives minus j omega RC. Okay, so this is the way you have to determine the transfer function of the differentiator. If you want to find the magnitude, so you have to take minus, so here the magnitude is minus omega RC. That is nothing but here we are taking absolute value, that is omega rc. Okay, so depending upon the omega value and r value and c value, so you get the corresponding response. If you want to draw the magnitude response, you have to take on x-axis, you have to take frequency, and y-axis you have to take magnitude g omega. Okay, so generally the magnitude response which is looks like this. Okay, for a differentiator which having a slope 20 dB per decade. Okay, so here in x-axis we have to take the frequency in terms of edges. Here we have to take in y-axis the gain, that is nothing but the transfer function magnitude, which is in dBs. Okay, so this is about how to determine the output voltage of the differentiator, what is the differentiator, and how to determine the transfer function of a differentiator. If you like my explanation, if this explanation is helpful for you, please like, share and subscribe for more videos. Thank you.